As I said, the summaries of all stoichiometry calculation problems are extremely similar. Therefore, to write down the summary properly is the key to identify a stoichiometry problem. Now let me show you the trick how to write down the summary properly. I will not go over all 8 problems. I will choose 3 of them. I will choose number 8 because number 8 is the only problem that does not have a balanced chemical equation. I will choose number 4 because number 4 will need more than stoichiometry. It also needs the density formula. I will also choose number 2 because number 2 is the longest problem of the 8 problems. To write down the summary, you have to read the problem very carefully from the beginning to the end. Then you need to search 3 different kinds of information. If you have a chemical reaction, the balanced chemical equation should be the first kind of information you need to look for. Then you need to search numbers with units. The last kind of information you need to search for is what we're looking for. What we're looking for is also very important in your summary because if you don't know what you're looking for, how can you proceed? Well, for this particular problem, we do have a chemical reaction. Therefore, we need to write down the balanced chemical equation. That's the first kind of information we need to put down. Then we need to search for numbers with units. Make sure in your summary you have to put down the numbers with units under the proper chemical. For example, 67 liters is for nitrogen. We have to put down 67 liters below nitrogen under the chemical equation. 3.00 mole is also for nitrogen gas. Therefore, we have to put down 3.00 mole under nitrogen gas below the chemical equation. I also put down a symbol to each number with a unit because all equations contain symbols, not numbers. If you can assign appropriate symbols to the numbers with units, it will be easier for you to find the equation to use. Then we have to put down what we're looking for as the last kind of information. We're looking for the mass in grams of sodium azide. Sodium azide is the first chemical in our equation. Therefore, we should put down the question mark below the first chemical. Well, this is the summary of our problem. To write a good summary, we have to read the problem very carefully from the beginning to the end. Then, we will search for 3 different kinds of information. If you have a chemical reaction, the balanced chemical equation will be the first kind of information you need to write down. Then, you will search for numbers with units. The last kind of information you need to write down is what we're looking for. What we're looking for is also very, very important in your summary. Because if you don't know what you're looking for, how can you get even started? Well, for this particular problem, we do have a balanced chemical equation. Therefore, I'm going to copy it down first. Now let's search for numbers with units. When we write down the numbers with units, make sure you put them down into the proper places. What I mean is, these 2 numbers with units are the information for oxygen gas. Therefore, in my summary, I have to write down both of them under oxygen gas below the balanced chemical equation. I cannot put it down somewhere else. Then, let's try to write down what we're looking for. We're looking for the grams of potassium permanganate. Therefore, I have to put down the question mark below potassium permanganate under the chemical equation. I cannot put down the question mark somewhere else. Well, this is the summary of our problem. In my summary, I assign a symbol to every number with a unit and what we're looking for. Because all equations contain symbols, not numbers. If we can assign appropriate symbols to the numbers with units and what we're looking for, it will be easier for us to find the equation to use. Well, as I showed in question number 2 and number 4, in the summary of a stoichiometry calculation, there must be a balanced chemical equation. Unfortunately, in question number 8, we are not provided a balanced chemical equation. But we do know there is a chemical reaction, because from the keyword combusted and react, we know there must be a chemical reaction. Actually, this sentence explains what combustion reaction is. It says hydrocarbons will react with oxygen to produce carbon dioxide and water. One way to get the balanced chemical equation is we can balance the chemical reaction by ourselves. But if possible, I want to avoid that. How can we avoid that? Let me show you how to do it from the meaning of balancing chemical equations. In this equation, I put down both the reactants and the products because we only care about the moles ratio between octane and carbon dioxide. If we can find the ratio between these two, we do not need to spend too much time to balance the entire equation. Well, when we balance the chemical equations, we want to make sure each side has the same number of each kind of atoms. For example, on the left, we should have the same number of carbon atoms as on the right. As we know, on the left side, only octane contains carbon. On the right side, only carbon dioxide contains carbon. Therefore, the ratio between octane and carbon dioxide must be 1 to 8. That way, we have 8 moles of carbon on both sides. We do not need to balance for oxygen and water. If you want, you can take out octane and carbon dioxide. After we get the stoichiometric ratio between the two chemicals, we need to find the numbers with units and what we're looking for. Put them down in the right places. 2.34 moles octane must be put under octane below this relationship. We are looking for the moles of carbon dioxide. That's why I put on question mark below carbon dioxide.